Hi, everybody. So today I'm going to start talking about the Python aspect of coding for the virtual robot. And I'll talk about it specifically with the obstacle courses. I encourage you to send me code in block format and or in Python format. So here we are in vr.vex.com. If I just put some basic blocks on there, I can always hit my code viewer over here. What you're seeing here is Python code that is used for the robot. It's kind of a specific dialect of VR, of Python code, if you want to think of it that way. So as we change things here, let's say I change that to 500, it just updated right here. I could add some more things, and you can see that it's all showing up in the Python code. And if you want to switch back and forth, one thing you could do is convert this to a text project, and it'll start over with the new code, or with the Python code. So let's think about the first obstacle course and think about what we need to do with it. It is right here. This is the first obstacle course, and this is a 500 millimeter grid. So we want the bot to go to the left or the right, to advance, and then turn and hit the tower. So let's think about this in Python. In fact, I'm not going to mess with this. I'm going to go ahead and start a new text project. Cool. So I start a new text project, and I've got all this stuff here. And by the way, the hashtags, these are all comments. This is a thing in coding. If you want people to understand the code that you're writing, you have to put comments in the code. So you put the green hashtag, and you can put anything after that. I could even put regular code after it, and it would cause it to jump over that code. In this case, I don't want to do that, but for example, if I were to put some commands in here, and I'm just dragging these over, if I wanted then to say don't do this line, I would just put a hashtag in front of it, meaning the code will skip right, the compiler will skip right over it. Okay. So for now, because we don't actually need any of these comments, I'm just going to get rid of all the comments just to clean things up. VR threads, do not delete. I'm not going to. I'm just going to delete the comment that says don't delete. All right, so here are our commands. I can always go over here and drag stuff over. And if I'm not sure about what goes in here, first of all, I can click on it and it'll autocomplete. So I'm pretty sure that the alternate command to forward would be reverse, and I just start it and it auto-completes for me, and I can just click that in. And then also I can go to that command over here and hit help, and it'll tell me lots of information. It'll show me an example at the bottom. If there are any options that I could add to it, it'll tell me. So, reading the help menu is a huge part of learning technology. So let's write something for the code. First of all, let me just put something at the beginning. This will work great for course 1. What do we want to do first? I want to turn. So I'm just going to use this turn for command, and I'm just going to drag it right up here. Instead of following the grid, I want to get creative here and do some diagonal movements. So first I'm going to start by turning right 45 degrees, and then just to remind you. So I'm going to turn right by 45 degrees, and I want to get to this cross point right here. Well, from geometry, I know that if I want to go for across the hypotenuse of a 45, 45, 90 triangle, which is a fancy way of saying, going diagonal across a square, then I know that the distance is going to be the edge times the square root of 2. And if you haven't quite gotten there in your math classes yet, it's okay. But, so instead of going 500, which is the amount I would go from here to here or here to here on the grid, instead, now I'm turning diagonally, I want to go 500 times square root of 2, which I just looked up, and it is 1.41. I can just multiply that stuff right in the code. And a lot of the time when we're using geometry in code, we can just do it this way and not even bother to multiply it out. How about that? So I could always copy and paste this stuff. I'll just keep dragging it over. And so I need another turn command to go third. And if you ever lose, by the way, the spacing on this, like if I had that, it's not going to run correctly because it needs to be inside this main loop to run correctly. But all I have to do to get it back is hit tab, and it'll jump right over and automatically get back in line. Great. So once I have gone forward to cross to that point, I'm going to turn left. And it would have to be all caps. Let's turn left for 45. So now what I would expect is that now I'm turning back to straight north. And I want to go, how many grid spots? 1 and 2. So each part of the grid is 500 millimeters. I'm just going to delete the extra space. One nice thing about Python code is that you can put a bunch of extra space in if you feel like it. It doesn't really make any difference. But if I'm going for 2 500 millimeter blocks, then I'm going to go forward by 1,000. And now I'm at this cross point, and I'm going to turn left and try to make a diagonal move right at the tower. So I'm going to turn left again in all caps by 45 degrees, and I'm going to get another forward movement. How far is this one? Well, 500 for the grid, and I'm going to actually repeat that movement from earlier. So I know the side of the square is 500, therefore the diagonal across the square is going to be 500 times 1.41. And once again, I'm not going to bother to multiply that. And then, so what I would expect from this code is that now the robot has gone forward and hit the Jenga tower and knocked it down. So what I would do at that point, let's just have a little fun with a victory dance here. And I'm going to put a repeat forever loop. And I always forget that it's a little different here. I'm going to take a while thing, and it has to be in line with all this other stuff. While expression, well, I'm not going to go into great detail on what I just typed here, but while 1 equals 1, actually, I think I put the extra. I don't think it actually matters now that I think about it, whether the space is in there or not. And what this is saying is, does 1 equal 1? Well, yeah. So that means we're going to run whatever's in here forever. I'm going to get rid of that, but I will put in a turn right forever. So it's just going to spin and spin after it has succeeded. And that's all. And that's something that would work great for the first obstacle course. I encourage you to find your own path through course one. If it's easier for you to follow the grid exactly and not worry about 45-degree stuff, that's okay. You can stick with 90-degree commands. But if you send me code like this, I can load it into the real robot and run it on the course and take some videos. So I'm going to go ahead and save this. How would I save it? Let's call it Obstacle 1, Obstacle Course 1. Now I have not saved it yet. I'm still going to go and save it to my device, just so I have that. Now, let's look at the other ones. Obstacle Course 2. Come on. Oh, it's back from there. This is going slow for me. Okay. Obstacle Course 2 is a little different, but the idea would be the same. You can get through it just by using go forward and turn, those same two commands. So it would obviously be different movements, but the general strategy would be the same. And so I'm not going to go into detail on that. But let me help you out a little bit with Obstacle Course 3. And just to explain what that is, the books will be randomly marked with red, green, or blue paper facing the bot. The tower will always be placed behind the blue stack. So the blue stack could be any one of these three stacks, and the tower will be behind there. So you would want to write code. Well, at least one way of doing it is to write code that is specific to each position. So let's just quickly try that. I'm going to open a new text project, and I'm going to get rid of all these extra comments. If you're a professional coder, it's your job to put these comments in so that other people can understand what you wrote. But I'm not worried about it right now. For this obstacle course, I want to check my front camera. So how would I do that? If is a crucial loop, because, or I shouldn't call it a loop. It's a crucial command to use. If the condition here is true, then we're going to do whatever is right here. And pass just means, I think it just means do nothing. And the reason they put that in there is because they don't ever want to have an empty loop. It is a conditional loop, I should say. Anyway, so we're going to go over to sensing. Front eye detect. The command in VexIQ is slightly different because it's a different sensor, but this will work. I will translate it as needed. If the front eye detects red, well, let's change that to if the front eye detects blue, then what are we going to do? Well, we're going to do some movement commands. I'm going to drive forward, maybe I'll turn, and then I'll go forward, etc. Obviously, that's not the correct movement for it, but that's the basic structure and the basic idea. Then, what I may wish to do, I'm facing forward. If this is the blue, then that'll work. The grid I just created will take care of it. Now let's turn left and check this side. So, if, and I need this to be in line with the other one, don't use the space bar with this because you might be off. Use the tab key. Use tab to move those to the different levels, whatever you call it. So if the front eye, oh wait, it's going to be a blue again. If front eye detect blue. But before we do that, we have to turn. My mistake. So back up in drivetrain, I'm turning right. Or I think I said left. Either way is fine. I'm going to turn left 90 degrees. Get rid of the extra space. So now, well, let me, you know what, let me just copy this. Again, it's not the right code for this spot. Oops. Copy and paste. And I just need that to line up. Yeah, so once again, it's not the right movements, but whatever the correct movements are, you would put them in that loop. And so what this does with this conditional loop, if the front eye detects blue, then we do this. But if the front eye doesn't detect blue, then we skip over whatever is in this loop, meaning we would check for the other thing. So this is the basic structure that you could use to get through the third obstacle course. And you can send me Python code. By the way, one really good way to post this would be in Discord. And you know what? Let me just show you that really quick while we're in the video. Oh, am I going to have to log in? Never mind. I'll just talk about it. So there is a way to post it in Discord. You would use the tick mark, which is all the way up in the top left. If you put 3 of those in a row before and after whatever you're typing, it'll be set off in what we call a code block, and it'll look a lot nicer. Okay,